Welcome, this is Mastering Triangle Area and Perimeter. So it talks about geometry, fundamentals, practical formulas, and it also explains clear definitions, key formulas for the area and perimeter of a triangle. Okay. So a definition of a triangle. A triangle is a closed 2D shape and polygon with 3 sides. Three angles, 3 vertices. And it also explains that the sum of interior angles has always got to be 180 degrees. So, it also talks about classification by sides, triangle types. So, it's a quick comparison of equilateral, isosceles, and scalene triangles. So, speaking of them, we're going to do an example of them. Okay, I'll do blue. Okay, so equilateral is 3 equal sides. Come here now. Show me. Be good. Stay out here. You're not allowed to go there as fast as you. All angles equal 60 degrees. So, the area formula. So it says that the area formula is the square root of 3 divided by 4. So, square root of 3 divided by 4. Times side squared. But I don't think that, well, I think that's the real formula. So isosceles. So isosceles is 2 equal sides, 2 equal angles. So it's kind of like this. Well, I can't show you my notes yet because I haven't got them all done. So, 2 equal sides. One of them has to not be equal. Okay, so scalene, no equal sides. So okay. The perimeter is a sum of all 3 sides. So like all triangles. A, B, C. For isosceles, it's A, B. For scaling, it's A plus B plus C. So 2A plus B is the isosceles. Okay, so now we're classifying triangles by angle. Acute, right, and obtuse. So, go ahead and divide this again. Break that down by section. Section 3, classifying triangles. Okay. Classify triangles. Okay. So now classifying triangles by angle. So acute angle. So all angles have to be less than 90 degrees. So, for example, an acute angle. Okay, so all angles are acute. So 60 degrees. So 60 is less than 90. So if an acute triangle has a 91 degree of angles, but it's an octave. So right, one of them has to have a right angle. 90 degrees. And all others are 45.
Shut up, buddy!
Okay. So, obtuse is one angle greater than 90. So, one angle needs to be greater than 90. So, for example, this is 110. This is 45. And the other has to be 15. 15 plus 45 is 60. Oh, wait. Then the other angle will have to be 25. My bad. So, the right has one perpendicular side pair. Obtuse is wider. Okay. So, the perimeter. One moment. Okay. So, perimeter is the total distance around a triangle. So, the definition, perimeter the perimeter is the sum of all side lengths. Okay, so it's measured in linear units. So measured in linear units. meters, and feet. So everyday analogy. Walking around a triangular park equals the perimeter. So the distance traveled along the three edges. So why does it matter? Foundation for the area formulas and Heron's method. So the perimeter reads the semi-perimeter used in Heron. Slide 6. So triangle perimeters. Quick formulas. Write the back this again. So we're going to talk about the formulas. If you want to, you don't have to do this, but I want to encourage you on making a table. So on the top left, put triangle type. So on the next right, put perimeter formula. And then when to use. So, general, put that on the top box of triangle type. Underneath, put equilateral. And put isosceles. So, for general, the perimeter is equal to A plus B plus C. For equilateral, put perimeter equals 3A. So, for example, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, 3 times 6 is 18, 3 times 7 is 21, so on and so forth. Then put perimeter equals 2A plus B underneath. P equals 3A. So P for perimeter equals 2A plus B. So when to use? A, B, C or no? Sorry. The reason all sides are equal. So, isosceles. Two lengths A and width B. Wait, base B, okay. Width, base, whatever you call it. So perimeter of a triangle has sides 5 centimeters, 7 centimeters, 9 centimeters. So, quick calculation using a general perimeter formula. So, given sides, A equals 5, B equals 7, C equals 9. So, a perimeter formula is A plus B plus C, which is a general triangle. Compute the perimeter. 7 plus 5 is 12, plus 9 is 21. So key insight. Uses the general perimeter formula in it for centimeters. So, area of a triangle, space measured in square units. So, 1. Area measures surface inside a shape in square units. So, units like a squares, like square centimeters represent surface covered. 2. Base times height formula. The area equals half times base times height. The height must be perpendicular to chosen base. 3. 3 sides known. Use for Heron's formula. Okay, so use Heron's formula. So compute semi-perimeter, then area from side lengths. So now number 4. Special cases, right? Isosceles, equilateral triangles. So special height relations simplify area calculations. So number 5. Inside, altitude must be perpendicular to base. So choosing the correct height is essential for all formulas. So triangle area. Area equals half times base times height. So use when a perpendicular height to a chosen base is known. So A equals 1/2 times base times height. So height requirement must be perpendicular to the base. Use the right height only. So applies to any triangle when height is known. So works for acute, obtuse, and right triangles. So area of a right triangle. Use the legs as base times height. So legs meet at right triangle and serve as base and height. The effect is use the two perpendicular sides directly. So area from A equals half times leg 1 times leg 2. So I wonder what leg 1 and leg 2 is. So that's the same effect as a cos. So example legs 4 centimeters and 3 centimeters equals area 6 square centimeters. So 4 times 3 is 12, divided by 2 is 6. So 6 centimeters squared. So compute triangle area with Heron formula. So find area when all 3 side lengths are known. So compute semi-perimeter S. S equals A plus B plus C divided by 2. And yes, we need to apply Heron formula as well. So area A equals the square roots of S minus A, S minus B, S minus C. Technically, that's the Heron formula. But I don't mind using square roots when it comes to applying triangle areas. So here an example. 3, 4, and 5 triangle area. So compute area using Heron's formula and verify with right triangle formula. So given sides and semi-perimeter, so sides equals A equals 3, B equals 4, C equals 5. Semi-perimeter, S equals 3 plus 4 plus 5 divided by 2 equals 6. Yeah. 3 plus 4 is 7 plus 5 is 12 divided by 2 is 6. So, apply Heron's formula. The area equals square roots of S times SA in parentheses, then S minus B in parentheses, and S minus C in parentheses. So, square root equals 6 times 3 times 2 times 1 equals 6 square units. So, verify with right triangle area. So, the right triangle area equals half times 3 times 4 equals 6 square units, matching Heron result. If you have any questions about the Heron formula, write it down in the comments. 3 more slides. Area of an equilateral triangle. The area formula is square root of 3 divided by 4, a squared, specialized for equilateral triangles. Worked example. So, for side A equals 4, A equals square root of 3 divided by 4 times 16 equals 4 times square root of 3. It's approximately equal to 6.93 square units. It feels like I've been talking forever, so derivation insight. So drop out the 2 to apply Pythagorean theorem to get height. Square root of 3 divided by 2a. So, real world uses triangles. So, architecture. Triangles used in trusses and roof structures for stability and load distribution. This is real world. So, area and perimeter guide material estimates, instructional calculations. Like my roof is kind of like steep, and it's a composite figure. We will be measuring that in our next short or something like that. So, surveying. Triangulation uses triangles to determine distances and map features. For design and signage, triangular shapes in traffic signs and graphic composition. So for surveying, triangle geometry enables recurrent distance measurement and mapping, and design and signage, perimeter and area help plan materials and visual balance. One more slide. Key triangle perimeter and area formula. So, quick reference for common triangle types. Perimeter equals P equals A plus B plus C. Equilateral, P equals 3A. Isosceles, P equals 2A plus B. Area, A equals half times base times height. Right triangle, half times leg 1, leg 2. Heron A, square roots of S times S minus A in parentheses, S minus B in parentheses, S minus C in parentheses. Equilateral equals square root of 3 divided by 4 times A squared. Thank you for watching. Have a good day. Oh yeah, And make sure you like and subscribe to my channel. Oh yeah, and don't forget to ask questions if you need to. If you need any questions, go down in the comment section under the video that you watched. And if you have questions about the video, put it in the comments. Thank you.